Well, hello folks. Thanks for coming. Well, recently I was inspired by an argumentative sort of chap named Bev, who runs a channel called Try Thinking, which is kind of funny because based on his YouTube channel content, this fellow actually thinks Earth is flat. Yes, you heard me correctly. So Bev has challenged me to a proofathon, where both of us present proofs of chosen concepts in science or mathematics. I thought it would be fun, so I decided to do a series of videos called Mystery Proofs in Science and Mathematics. So here goes a simple one to kick off my part of the project. Hope you enjoy it, and indeed the series. And if anyone has some ideas for an interesting proof in a science discipline or mathematics, please put it in the comments below. And please feel free to dislike or subscribe and hit the bell button while you're watching, or perhaps even now. So today I'm going to indulge in a bit of fun by going through a really delightful proof for one of the most important and therefore popular theorems in the discipline of geometry. And I'll keep the punchline to the end, so please stay tuned for it. I know you'll get a kick out of it, so without any further ado, let's begin. So let's begin with a right triangle. Let's label the sides A, B and C. And let's label the small angle theta. And of course, knowing the internal angles of a triangle add up to 180 degrees, and the right angle being 90 degrees, means that the remaining angle must be 90 minus theta degrees. Now let's make an exact copy and rotate it 90 degrees to the right. The two triangles are an exact copy, so they're congruent. Now you have the left side A plus B, and on the right we have two sides in green labelled C, forming an angle. And although it looks like the two green sides seem to meet with an angle of 90 degrees, we can't just assume that they do. We need to prove it. So if you consider the three angles theta, x, and 90 minus theta, they form a straight angle which is 180 degrees. So the theta plus 90 minus theta plus the unknown x add up to 180 degrees. So if you consider the three angles theta, x, and 90 minus theta, they form a straight angle which is 180 degrees. So the theta plus 90 minus theta plus the unknown x add up to 180 degrees. The plus theta and minus theta cancel out, leaving 90 degrees plus x equals 180 degrees. If we move the 90 degrees to the other side, we are left with x equals 180 degrees minus 90 degrees. So finally, we have proved that x equals 90 degrees, hence a right angle. Now let's label the corners A, B, C and D and draw a line from A to B to create a trapezium A, B, C, D. Now remember that the area of a trapezium is half of the sum of the base plus the top times the height, which is the same as the average of the parallel sides times the height. In this case, we get half A plus B times the height, A plus B. Now let's compare the area of the trapezium with the sum of the areas of the triangles that make up the trapezium. First, we have three triangles, red and blue and green. And all three compare in area exactly with the yellow trapezium on the left. Now both the small triangles are identical with area half A times B. So half AB. And we also have the large green triangle with area equal half the base times the height. So that's half C times C, or half C squared. Now let's get down to a bit more serious algebra. First, notice that each element in the equation is multiplied by half. So this means we can cancel all the halves. This is the same as multiplying everything by 2. we don't need to. This is just a shortcut. This leaves us with a plus b all squared equals 2 lots of a plus b and c squared. Now remember your grade 7 algebra. A plus b all squared becomes a squared plus 2ab plus b squared, which of course from the previous slide is equal to 2ab plus c squared. Now that we have plus 2ab on both sides of the equation, we can cancel out our 2ab's from both sides of the equation. So what have we got left? Yes, you've got it. A squared plus b squared equals c squared. Proof of Pythagoras' theorem. Of course, there are quite a few ways of proving Pythagoras' theorem, but I quite like the elegance of this one. But I'm not taking the credit. Who should get it? Well, wait for it. Well, it's none other than the 20th President of the United States of America, James Garfield. We don't usually think of politicians as being mathematically gifted, but there it is. Well, this proof was not just elegant, but simple to follow, and no doubt Bev and his flat earth friends got a kick out of it, given their talents in geometry. Anyway, to everybody, thank you very much for staying to the end. I hope you enjoyed this proof as much as I enjoyed putting this together. Please like and subscribe. Shortly I will release another proof, and this one is surely destined to create controversy. Cheers.